Hello students, here we have a problem. Uniformly charged sphere. That means charge is uniformly distributed across this sphere, okay? Uh, we have a charge which is positive. This sphere is positively charged. It has a radius. Now we have to find what is electric field at a half distance of the r, which means let's say that we want to find electric field at this distance, and then we want to find what is electric field at a distance of say r. Okay, so say it's here er. So that's two things we have to find it. Now if you don't want to derive anything, then basically you can just use the ready formula, which is given actually is this one. This is a formula which is already given. You can use it, but however, if you don't know this formula, then you have to start deriving a formula for it. So how can we find it? So what is the easiest way to find E at small r, or at any r, or in a halfway of that one, or and so on? Okay, since it's uniformly charged, that means charge is everywhere inside the sphere. Okay. First of all, I think we can easiest way. I think we can use the ratio. Okay, defining the ratio. So say that we have a charge dash inside this certain area. Okay, and then we have a total charge which is whole sphere. Okay, now we know that charge actually is proportion to the volume. Okay, in this particular case. Now the formula for the volume is equal 4 over 3 pi r cube. Okay, now if you want to find the ratio, then what you do is basically you say that q dash, okay, at any r, at any small r, okay, at any small r is equal to what? It's 4 over 3 pi r cube, right? Then we have a total charge entire sphere. Then we can just take the q, and this one is equal to 4 over 3 pi and total radius r cube. Okay, then what you do then this thing will cancel with this one, pi cancel with pi. Then at the end you will get q dash is equal to the q multiplied to the r cube, any r cube small, divided by r cube big one. Okay, so now we got basically the ratio of finding the charge. Now you can use another way of finding the things by using the density, because density is a constant and so on, but you will get to the same point. Okay, now we know that area of, if you want to measure the electric flux, say that at a distance of small r, okay, at a distance of small r, this one, then you have to draw a Gaussian surface, and by the formula again it's defined by flux is equal E times A, which is equal to the Q enclosed divided by epsilon naught. Okay, now what is the area of this small r? That one will be what? E times 4 pi r squared. Okay, then what we have to do after that? So since we want to find electric field at small r, or any small r, then we can say that E small r is equal Q enclosed divided by 4 pi r squared epsilon naught. Okay, now 4 pi epsilon naught, 1 divided by 4 pi epsilon naught gives you k. Okay, so that means you can say that k, Q enclosed divided by r squared. Okay, then after that what we have to do now, Q enclosed, or we want to find what is the how much charge is inside this a small area. Okay, inside of this small sphere. That means we already found it, which is equal to this one. So that means we can say k multiplied total charge r cube divided by small r squared and r cube. Okay, so this r with that one will cancel. Then you should get like k q r divided by r cube. Okay, so finally we came to this formula where electric field inside the sphere at any r, small r, is equal k q r divided by r cube. Okay, now in our case it says that at the halfway of the sphere, that means capital R divided by 2. So that means if you plug it here, so k q, this is r divided by 2, here we still have r cube, then this will cancel this one, then k q divided by 2r squared. Okay, now this is the halfway of the r2. So let me just write down here that it's r over 2. Okay, then if you want to find electric field just here, then what you do is again come back to this formula where is E capital R is equal k q, you put here capital R divided by r cube, then this one will cancel this one, so k q divided by r squared. That's it. So if you plug numbers, then you get the answer.